Hello everyone, I'm Eric Higham with Microwave Journal, coming to you from IMS 2024 in Washington, D.C. And we're at the Mercury booth, and I'm with Rudi Skaf. And Rudi, you've shown some products here. What can you tell us about the product developments and particularly the MMIC development that you folks are doing?
So we see a lot of trends happening. The three main ones is we're seeing customers need smaller form factors, higher densities, and there's a growing interest in direct RF. Small form factor and higher densities go hand in hand because customers are not only looking for reducing size, but also increasing the functionality of a product. And we think having MMIC design capabilities helps us here, as we can take the different portions of the block diagram and design them into one single chip, or take several different single function chips and package them into a multi-chip module. From the direct RF standpoint, we are heavily focused in this area with our mixed signal team, and they are working closely with all of the suppliers developing these high-speed A to D, D to A's that are directly digitizing up to 18 gigs or higher. That eliminates the need for conversion in the analog space, but you absolutely still need signal conditioning, and you need to do some sort of channelization. And we think our product line of MMIC tunable filter banks, switch filter banks, our MMIC high dynamic range amplifiers, our high linearity switches, and our MMIC passive components will play a key role in the signal conditioning of these direct RF architectures.
So can you talk to us about the new MMIC capabilities that you've developed?
Sure. So from a new capability standpoint, we're moving higher in frequency and higher in power, both output power and input power handling. So a good example of moving higher in frequency is our AM9035. That's actually a connectorized module. It's an 18 to 44 gig receive tuner with a fixed IF output of 3.8 gigs at a 2 gigahertz instantaneous bandwidth. 90% of the MMICs inside of it were developed by us, specifically a 18 to 44 gig switch filter bank, along with various millimeter wave amplifiers. From a high power standpoint, we're starting to get into GaaN designs. So our first GaaN amplifier is a 5-watt X-band power amplifier. We're going to be releasing other narrowband and broadband GaaN PAs. And from an input power handling, we're looking at GaaN to design GaaN LNAs, GaaN switches, etc.
So what differentiates the Mercury products? What makes them unique?
So I think what makes our MMIC capabilities unique versus others in the industry is we're not designing parts to fill a gap in the catalog. Our MMIC designers have a long history of system level design, so they know the headaches that they've run into at a module level, at a board level design, and what semiconductor devices can help simplify that, solve problems at that next higher level. So everything's designed with a purpose. It's not just to fill a gap in a frequency range. Everything is designed in a way that either the package size is made in a way that you can fit the board layout better, or there's certain specifics in an amplifier and another component that will help give you more margin at the next higher assembly.
Now you mentioned system level design. What are you doing in that area?
So our MMIC design team doesn't just design MMICs, they also do module design. And we also have a microwave group that does custom integrated microwave assemblies, both chip and wire and surface mount, for our mil-aero and our space customers. And specifically, our MMIC design team is also creating board mount tunable modules. A good example of that is the AM9017. It is a 1.4 by 2.7 inch board mount tuner that takes in 0.1 to 18 gigahertz input and an output of 1 gig IF fixed and 500 meg instantaneous bandwidth. And that's, given its small form factor, allows our customers to really increase the channel count in their systems.
So where does the MMIC product line fit within the Mercury product portfolio?
So within Mercury, we have what we call the processing platform. It's to help give customers context on what we can do within a sensor chain, from our capabilities from right behind the antenna all the way to the back-end server processing, and from chip level all the way to system level. And most sensor chains have an analog signal right behind the antenna for your transmit, for your receive. And MMICs play a crucial role there because if you have high performance MMICs, they help increase the integrity of that analog signal, which causes a ripple effect of success throughout your entire sensor chain.
Well, great, Rudi. Thank you for sharing that information with us. And signing off from IMS 2024 in Washington, D.C.